In this problem, you want to remember that if you have an alcohol, this can react with aldehydes to make hemiacetals. Okay, hemiacetals are where one half is kind of like from the alcohol and the other half is from the alcohol. You also want to remember that hemiacetals can react with added alcohols. I'll do it in a different color so you can see what's going on here. It can react with a second equivalent of a different alcohol, for example, to give you an acetal. Okay? Now, the trick here for this problem is to realize that we've got this tether here that's tying together the aldehyde and the alcohol. So, there's a loop here, right? That connects the alcohol with the aldehyde, and so you're going to have a loop here, a ring. Okay, so that's a ring that's being formed, and here's your ring. I'll just draw a circle. It's not aromatic. I'll just draw it shaded in. And so, now you have like an OH group that gets substituted for this purple thing because we have ethanol in there too. So this is the first stage. We're going to take our molecule and zip it up, make a ring as a hemiacetal. Okay? Then what we'll do is we'll react this with ethanol, again under H+ catalyst to give the acetal. Okay? So let's see how this works. Remember that if you have acid, you're going to use that in the first step of your mechanism. So we want to take these lone pairs on oxygen and go ahead and attack H+, which is our catalyst. From this step, we're going to get a protonated. Now some students ask, well, why don't you protonate the other oxygen? You could, you can, but remember all these steps are in equilibrium, and the correct pathway is to protonate the carbonyl oxygen of your aldehyde. Okay? Why? Because in this step, we're going to need to take lone pairs on our alcohol and attack the carbonyl carbon. So this is going to give us a ring. Now I'll redraw it all nicely, but it's going to look like this. Okay. Draw the H, and then here's the OH. So let me orientate you here correctly. So here's the oxygen of my alcohol that attacked. Okay, let's make sure we have the formal charge of plus on that guy. So that oxygen is attacking the carbonyl carbon, so it's forming this bond right here. Okay, and the electrons are pushed up onto this oxygen, right? So now it has an octet. Its formal charge is 0 there. Okay, now I want to deprotonate this guy here. So there's water floating around, and so we want to use that as the general solvent to deprotonate here, and that's going to give us the hemiacetal. Now I'm going to drop off this hydrogen. It's just kind of annoying to keep showing that. Okay, so this guy here is the hemiacetal. So we've done stage 1. Now what we want to do is react this hemiacetal with ethanol in acid to give us that molecule. So we need to get rid of this OH, don't we? So the way we do that is we attack H+, okay, and that's going to give me a protonated alcohol. Now remember, neutral water is a pretty good relieving group, so that's the purpose of doing this. And what we're going to do now is take the lone pairs on this oxygen guy here and kick off water. Okay, so here's where you lose water, and we form this very weird looking structure. Okay, this is all to avoid a carbocation. It looks weird, but it's better than the alternative. resinous structure I could draw. Now we want to take ethanol, which is floating around, as a reaction solvent, right? So here's ethanol, and we want to attack the carbonyl carbon, okay? Kicking up those electrons to the oxygen. This is the nucleophilic addition stage. And I'm, kind of almost there. I've got my ethyl group, so that's good. And now actually, you know what? I should have used, pardon me, but this is not a hydrogen. This is ethanol, which is my solvent. Okay, there's not water solvent. There's ethanol that's a solvent. So correct that if you're copying this down. Okay, so here's where I now need to use ethanol as my solvent. That's going to do the general acid-base reaction, deprotonate, to give me the neutral molecule. So I'm going to call this the target molecule, and I'm going to label the final product here in this reaction mechanism the target molecule. So that's how you do this step. It's nothing more than making a hemiacetal and then making an acetal. It looks weird because they're rings, but that's basically how you do it.